In this problem, we're going to talk about simple genetics. We're going to say that brown is dominant to blue in eye color. And we're going to take two heterozygous parents for brown eyes. So when you're working out one of these chi-squared problems, the first step is you have to do your Punnett square to see what the predictions are. So we're going to take two heterozygous blue eyes. We get a 75% chance of having a brown-eyed child and a 25% chance of having a blue-eyed child. So how many phenotypes do we have? In this one we just have brown and blue. So we can get rid of this whole row completely. And let's say that these aren't humans, that they're mice that have weird blue eyes, which mice don't have, but and let's say these mice have 302 babies with brown eyes and 118 babies blue eyes. You're going to have to be able to calculate the expected value by yourself, and to do that you take the predicted percentage from the Punnett square, which was 75% for brown eyes, and you have to change that into a decimal. So we take 75% chance of brown eyes, and we have to multiply that by however many children we ended up having. And in this case, it is 420 children. So we take 420 children times 0.75. Get your calculators out. 420 times 0.75 is 315. And then for this one, we expect 25% of them to be blue-eyed. So we take 0.25 times 118, and we get 105. You gotta put it in your calculator. And so then you work out the chi-squared step by step. This minus this. 315 minus 315 minus 302 is 13. Go ahead and square it. 169. Take that number divided by the expected number. 169 divided by 315. Not a very big difference between our expected and observed here. So that means this is probably just simple Mendelian genetics, but let's check this one. 118 minus 105, square that. It's the same thing. But it's not going to be the same answer here because we're going to take that number and we're going to divide it by our expected. So this time we're going to divide by 105. And we get 1.6, 1. Add those numbers together, and you get a sum, that's important, of 2.14. You have to make your formula sheet your friend. Make it your friend. Here's the formula for chi-squared. That's what we worked out in the chart. This tells you everything you need to know. Your observed values, your expected values, and here's the definition of degrees of freedom. The number of distinct possible outcomes minus 1. How many outcomes did we have? our degrees of freedom is 1. So we come here to our chi-squared table, and we use the 1 column, and we can pick either one of those values. This is the 0.05 level is standard in science. Shouldn't be, but it is. We're going to go with 3.84 for our critical value. These are called critical values, the value at which you can reject the null. Memorize this. Because the chi-squared value of 2.14 is, you have to choose, and our critical value is 3.84. So that is our chi-squared value. That's our critical value. That one's less. So because the chi-squared value of 2.14 is less than the critical value of 3.84, we failed to reject the null. Nothing interesting is going on here. It's probably following normal Mendelian genetics. It looks like it is. Good luck.